Okay. Um, June 2024, paper 3, variant 1. Hmm. Question 1. Figure 1.1 shows the speed time graph for a car. For the graph in figure 1.1, match each letter R, S, and T with the motion at that point. So R basically was accelerating, positive acceleration. S, let's check out S. It's a horizontal line. So this is moving. Yes, it is moving at a constant speed or with a constant speed. So S moving with a constant speed. What about what about T? Let's check out T. What's happening to the speed? The speed is decreasing. Yes, so it's decreasing. Hmm. T is decreasing at a constant deceleration. If you might say, yes, it is moving or it is decelerating with a negative deceleration. When would it be at rest? That's a good question. If it was at rest, it would have been at this point, for example. This is at rest. This is at rest. So the value of the y-axis should be zero. Y-axis is the speed. Whenever the y-axis reaches zero, this is at rest. Um, Question. Okay, I determine the speed of the car at 4 seconds. So at 4 seconds, we should draw a line. Okay, a vertical line. Let's zoom in. Hmm, Let's zoom in. Check. The vertical line reaches this point exactly. Right? It reaches this point exactly, which is just above. Just above what? It's just above 17.5, isn't it? It's just above 17.5. So can I reach an exact point? Can I reach an exact point? Yes, I can. Okay, let me remove this line again. At this point, at this point exactly. Let's see. So each of these small squares is worth what? If you can find these small squares, 15, 15.5, 16, 16.5, 17, 17.5. So this is 17.5. At this point is 17.5. But the line did not reach this point. Actually, it exceeded this point. It has actually exceeded this point. And if we zoom in even further, let's zoom in even further. Can you check this point? At this point exactly, this is above 17.5 and just below 18. So this is 18 and this is 17.5. It's 18, it's between 18 and 17.5. So if you say, for example, 17.75, which is exactly in the middle between them, would that be correct? Yes, it would be correct. Okay, it's in the center. So if you say 17.7, okay, 17.8, yes, okay. Okay, why? Because it's in the middle between 17.5 and 18. No, it's not 17.5. Again, this is not 17.5. This is just above 17.5 and just below 18, which is somewhere in the middle. So it would be 17.75 to be very exact. Okay, 17.75. So let's zoom out again. 17. Yeah, let's write it down. 17.75 meters per second. Okay, okay. Moving on. Determine the distance moved by the car from 16 to 20 seconds. Distance moved in a speed time graph. Distance moved in a speed time graph. This is what area under the graph. From 16 to 20 area under the graph. We can shade this area, which is an area of a triangle. Yes, it's an area of a triangle. Area of a triangle. So this is half times base times height. Half, you have to write down area under the graph, which is half times base times height. So the base is 4. Yes, the distance between 16 and 20. Distance is 4. 20 minus 16 is 4. And the height is 20. The height is 20. Yes, it's from 0 all the way up to 20. So half times 4 times 20, which is 40 meters. Yes, this is the exact distance. Define the term velocity. Define the term velocity, which is a rather new question. We do not have many questions concerning velocity. Why? Because it was added to the syllabus quite recently. It is, yes, it is a speed with a direction. Yes, you might say it's a speed with a direction, okay, or in a certain direction, whatever. Okay, speed with a direction, okay, or in a certain direction. Rate of change of, no, it's not the rate of change of acceleration. No, no, that's wrong. Okay, it's not the rate of change of acceleration. Yeah. Speed with a direction. Someone might say, this is a more complicated answer actually, that it's the rate of change of displacement, which is a much more complicated answer. The very simple answer would be it's a speed with a certain direction or in a given direction. Okay. Moving on to question two. A student places six 100-gram masses in a stack. Okay, and then you have the height of the stack is 5.4. Can I find the average thickness of one mass? Yes, I can find the average thickness of one mass. How can I do that? By division. You divide the total length by the average thickness of one of these. So basically, it's 5.4 divided by 6. 5.4 divided by 6, which is 0.9. Yes, you do not need the mass for this question. You just need the height. Moving on to B, figure 2.2 shows the masses a measuring cylinder and a beaker containing some water. The student uses the equipment to determine the total volume. So all you need to do is find the volume. We do not need to find the density for this question. We do not need to find the average density. So describe a method that the student uses. How can he find the volume? How can he find the volume? Basically, by the displacement method. Add some water, add the masses, V2 minus V1. That's it. So add water to the cylinder, add water to the cylinder, and take the reading. Take the reading. We will call it V1. Add some water to the measuring cylinder, take the reading V1. And then add, okay, the masses to the cylinder, okay, not the cylinder, to the cylinder, and take the new volume, of the water and the masses of the water and masses, we will call it V2. To find the total volume, or to find the volume of the masses alone, okay, volume of masses would be equal to V2 minus V1. Okay, so basically in A, what we did was finding the average thickness of one mass. He does not want to find the mass. He's finding the average thickness of one mass. So I found the total thickness, which is 5.4 divided by the number of masses, which is 6. So 5.4 divided by 6 is 0.9. In B, all we did was find the average volume because we can consider it to be an irregular shape, even though it's not an irregular shape. But anyway, finding the volume by the displacement method, adding some water and then adding the masses, then finding V2 minus V1, which is a very popular question. We have it a lot in paper 3. Question 3. Calculate the resultant horizontal force. Yes, the resultant horizontal force would be 200 minus 80, which is 120 newtons. The direction would be forwards. Why? Because the 200 is much greater than the 80. 120 forwards. Suggest what causes the 80 Newton force on the boat. It's a backward force. It's against the motion. It's a force against the motion. What type of friction? Well, that's the question. We have several types of friction. Basically, or usually when we say friction, it is between two solid surfaces. When we say friction, it is between two solid surfaces. Yes, air resistance would be a much more reasonable answer. Okay? Would be a much more reasonable answer. Air resistance. You can also say water resistance. It's not wrong. Okay? You can say drag. Sometimes instead of saying water resistance, we say drag. Describe another boat is traveling and the horizontal forces on the boat are balanced. Describe the horizontal motion of this boat. Hmm. If the resultant forces are balanced, then it is. It is. No, it's not at rest. No, it's not at rest. It's actually constant speed. Okay, it's moving with a constant speed. Because why is it moving with a constant speed? Because there is a forward force and there is a backward force. So these forces are equal. When they are equal, the boat is moving with a constant speed. There is a forward force. If the forward force is zero, that's the question. If the forward force is zero, therefore, or then the boat would be at rest if the forward force is zero. But since you have a forward force of whatever value, 200, for example, in this question, and you have a backward force of 200, they would be equal. Therefore, this boat would be moving with a constant speed. Okay, which would yeah you could say it's moving. It is equilibrium. You can say it's moving. It is in equilibrium. That it will not move. No, it will move. It will move. It will. Hmm. Okay, B, calculate the moment. How can I find the moment? Moment equals force times perpendicular distance. So the force is 60 newtons and the perpendicular distance is 50. So 60 times 50 is 3000. What is the unit? We have forces in newtons, and the distance is in centimeters. So basically Newtons dot centimeter. Newtons dot centimeter. You cannot say per. You cannot say slash. Slash is wrong. Newtons dot centimeter. Slash or per is when you divide. Okay, it is when you divide. Yeah. Next question. The government of a country decides to reduce the amount of fossil fuel burned for generating electrical power. State two reasons apart from cost for reducing the amount of fossil fuel burned. Basically, we want to find disadvantages of fossil fuels. How can I find, or what are the disadvantages of fossil fuels? Or, in other words, why would they want to do that? Pollution, okay. Instead of just saying pollution, we need to specify the type of pollution. So we can say to decrease the amount of air pollution, okay? Or because the fossil fuels contribute to the air pollution. Okay, so it's giving off air pollution. Please do not just say pollution. Okay, global warming. Yes, non-renewable. Yes, it is also a an acceptable answer. Okay, non-renewable. No, it is reliable. It is reliable. Renewable and reliable are two different things. So non-renewable. Okay, describe how hydroelectric power station generates electrical power. Okay, hydroelectric power station, the dams. Okay, how do dams produce electrical power? Because of the height of the water, so on. We need to state the electric or the energy changes. We need to state the energy changes through that can produce the electrical power at the end. There's a question. What is the difference between renewable and reliable? Renewable means that it does not end, that is, it is regenerated, that it will not finish. Reliable means that you can depend on it at any time. So it is there in the morning, at night, during winter, during summer, during any season, and at any place in the world you can generate electricity using the coal-fired power stations. That is what I mean by a reliable power source. Okay, so let's start. How can I produce electrical energy from this hydroelectric power source? Basically, the water behind the dam, okay, has what type of energy? First of all, you have to say that the water stored behind the dam has gravitational potential energy. Yes, thank you. Okay, so water behind the dam has gravitational potential energy, which is then converted to what type of energy? Hmm. Converted or oh no, again with the pen. Hmm. Converted to kinetic energy. Yes, thank you. Okay, converted to kinetic energy as it moves, hmm, as it moves through the pipes, through the pipes, which then do what? Which then rotating, yes, rotating the turbines, which in turn rotate what? No, the turbines do not produce electrical energy. The turbines by themselves do not produce electrical energy. The turbines have to be attached to a generator, which rotate. A generator, a generator that produces electrical energy. That produces electrical energy. Okay, so basically the last transfer of energy was from kinetic to electrical. Two disadvantages of hydroelectric power stations. Not reliable. Actually, it is kind of reliable. It is kind of reliable. What else? What other disadvantages do we have? Yes, okay. It does destroy some animal habitat. It does kind of destroy the environment. Okay. Animal habitat. Okay, sorry for that. Okay, so it destroys the animal habitat. Yes, it does destroy the animal habitat. What else does it do? It causes flooding. Yes, it causes flooding behind the dam. Causes flooding behind the dam. Hmm. Behind dam. Hmm. Okay. Should we memorize the advantages and disadvantages to a good extent? Yes. You should know them well. The government plans to build some wind turbines. The government plans to store some of the electrical energy generated by the wind turbines. Suggest one method of storing the electrical energy generated by by a wind turbine. Hmm. How can we store this electrical energy? How can you store this electric? Yes, exactly. In batteries. That's it. In batteries. In batteries. So someone's asking, how can the dams cause floodings? It actually causes floodings behind the dam, not after the dam. It causes floodings behind the dam. It creates these artificial lakes behind the dams. So you kind of destroy even furthermore the environment which is behind the dam. Okay? Okay. Um, yes, yes, it is said in Arabic. Describe the arrangement, separation, and motion of gas particles. Arrangement, first of all, irregular. Yes. The separation, far apart. Yes. What about the motion? Motion, fast and random in all directions. Yes. So let's write them down. Arrangement, irregular arrangement. You can say random, not fixed. Hmm. What about the separation? Yes, if they are far apart. And last but not least, the motion would be fast and random in all directions. Okay, good. Figure 5.1 shows some gas in container. Calculate the work done by the 13 Newton force. How can I find the work done? Work done equals force times distance moved, not perpendicular distance. Force times distance moved. What is the force? It is 30 newtons, and the distance moved is 0.18 meters. So basically, the work done would be 5.4 joules. Yes, 5.4 joules. When the piston moves into the container, the temperature does not change. The temperature does not change. What changes? The pressure changes. Describe and explain any change in the pressure. So as the volume decreases, what happens to the pressure? Pressure, hmm, yes, it does increase. Why does the pressure increase? Why does the pressure? Yes, because they hit the walls more frequently. That's an excellent answer. Because they hit the walls more frequently. Pressure increases. Why? Because they hit the walls or molecules hit the walls more frequently. Okay, excellent. Moving on. A student wants to compare the conduction of thermal energy. We have four rods: iron, copper, glass, and aluminum. Describe how the student can compare the conduction of thermal energy through the rods in figure 6.1. How can I know which rod is the best conductor? How can I know which rod is the best conductor? Basically, yes, basically by attaching a small pin with some wax to the end of each of these rods. Okay, this is not a thermometer. No, no, no. You will not actually measure the temperature. No, you don't need a thermometer in this question. Okay, attach. Okay, attach small pins using wax at the end of each rod. At the end of each rod, and then what should you do? The wax or the pin that falls first is attached or was attached, whatever, to the best conductor. To the best conductor. Okay. Well, a Bunsen burner emits infrared waves. They have a wavelength of 2 times 10 to the negative 6. The speed is 3 times 10 to the power of 8. Can I find the frequency? I definitely can. How can we find the frequency? How can we find the frequency? Someone tell me. Oh, someone help me out. Frequency is what? What's the equation? Frequency equals speed over wavelength. So please, on your calculators, um, use the fraction sign. Use the fraction sign to write it down. How can I use the fraction sign? 3 times 10 to the power of 8 over 2 times 10 to the negative 6. Use your fraction sign on the calculator. So this would give you actually a large frequency, which is around 1.5 times 10 to the power of 14. 1.5 times 10 to the power of 14 hertz. A huge number, which is quite normal for the frequencies of electromagnetic waves. State the name of a region of the electromagnetic spectrum which has a wavelength longer than the wavelength of the infrared. Give one use of this radiation. Okay, microwaves, yes, or radio waves, yes. No, gamma rays is wrong. Okay, gamma rays are wrong. Microwaves and gamma rays have a longer wavelength and frequency much shorter. Gamma rays have much larger frequency. Okay, the use would be in satellite transmission. Satellite transmission. How can I find the frequency? 1 over the period. Yes, if you have the period, but you do not have the period. Hmm. The angle of incidence is 40. Indicate the angle of reflection by drawing a letter R on figure 7.1. So this is the angle of refraction. R. State the size of the angle of reflection. If the angle of incidence was 40, therefore the angle of reflection has to also be 40. Yes. An object O is placed to the left of the thin converging lens. Two rays from the top of the object are incident on the lens. Hmm. On figure 7.1, locate the image of O by continuing the path of each ray. Okay, so the first ray, which was parallel, it has to be refracted and it will pass through the focal point, pass through the principal focus. It will refract and pass through principal focus in a straight line, definitely using your um, rulers and a very thin pencil, please. Okay, draw a line passing through the principal focus, which will continue straight in this direction. And then the second line, which is passing through the center, what will happen to this line? Will it refract? No, it will not. It will continue in a straight line and it will intersect with this line at this point. To find the image, how can I draw the image? Please, you have to draw the image this way. You have to draw an arrow pointing or starting from the principal axis, reaching the point of intersection, and he didn't say that you have to name it I, but we could name it I image. Okay, draw an arrow to represent the image. You have to draw the arrow this way, please. You have to draw this arrow this way. If you do not, you will lose a mark. It's as simple as that. Okay, moving on. Figure 7.3 shows a prism. The prism refracts the white light. I or OI, because it's the image. I is the image. State the name of the effect that produces this spectrum. What is the effect that produces this spectrum? Diffraction? Is it diffraction though? Is it really diffraction? Or is it dispersion? Yes, dispersion. Okay, it is dispersion. Dispersion. List the name. Can I write down the names of the colors? Yes, I can write down the names of the colors. Roy Gibiv. Roy Gibiv. So ROYGBIV. Red, orange, that appear between X and Z. So red, we know them all. Orange, yellow, green, blue, indigo, and violet. Excellent. Excellent. Yeah. Okay. Figure 8.1. State the material which is suitable for the core of an electromagnet. Core of an electromagnet. Yes, iron or soft iron. Iron or soft iron. It has to be a magnetic material, a non or a temporary magnet. It has to be a temporary magnet. The battery is made of cells connected in series. Each cell of the battery has an electromotive force of 1.5. Calculate the number of cells in the battery in 8.1. So the total voltage is what? 12 volts. This question, you do not have only two cells. It has drawn only two cells, but basically you actually have more than two cells. You can have three, you can have four, you can have five. I have no idea how many cells would we have. But to find the number of cells, what do? We take the total voltage, total potential difference, total EMF, electromotive force, and we divide it by the voltage of each cell. So basically 12 divided by 1.5. 12 divided by 1.5, which is 8 cells. The switch is closed. The direction of the current in the solenoid is shown in figure 8.1. There is a magnetic field around the electromagnet. State the name of the equipment. Yes, to find the direction. To find the direction, we need a compass. Yes, we need a compass. Okay, that's easy. Plotting compass or a compass. The next question, part II, is rather difficult. We might have explained it very briefly, and you actually don't have that many questions regarding this very specific question in II. State the name of the pole labeled at X. The name of the pole labeled at X. So he's asking, is this a north pole or a south pole, basically? So how should you know that? That's a very difficult process, but basically using your right hand rule grip, the north pole would be at X. The north, this would be a north pole. I don't want you to fixate on how we did it for now. Maybe we can explain it further on or later on, but for now it's using the right hand rule grip. Okay, the X would have a north pole. Okay, north pole. AII, what did we do? Let me write down here. A. This is a North Pole, okay? And AII, what did we do? The number of cells, what did I do? The total voltage. I took the total voltage divided by the voltage of each cell. Divided by the voltage of each cell. Total voltage divided by the voltage of each cell. That's what I did to find the number of cells. Again, for BII, it's a rather difficult process. Okay, right hand rule grip. It's called right hand rule grip. Basically, the thumb would indicate the North Pole. I do not want to go into further details right now. But for C, it would be a very easy answer. How can I find the potential difference of the solenoid? The potential difference, which is the voltage, basically. So V equals IR. Yes, V equals, what's happening? V equals IR. So basically, the voltage, the current is what is 1.2, and the resistance is 8. V equals IR. So 1.2 times 8 is 9.6. Yes, thank you. 9.6 volts. Excellent. Okay, good. Next question, 9. State the name of each of the three wires. We have three wires, which are like the positive wire, the negative wire, and there's a third wire. What's the positive wire? We don't call it a positive wire. We call it what? Live wire. Remember, the live wire is the positive wire, and the negative wire is called the neutral wire. What's the third wire? The third wire is the earth wire. It is the earth wire. So you have a live wire, the positive, which is basically has all of the current, the neutral wire, and then you have the earth wire to protect it from, or to protect you as a user from any electrocution. So just one hazard due to a current of 30 amperes. So if this wire is designed to sustain 13 amperes, one hazard due to 30 amperes, if you increase the current too much, when you increase the current too much, what happens? What happens? Yes, overheating. Overheating. Overheating, yes. That's why we have fuses. That's why we have fuses. There is a transformer. Okay, so you have the VP, NP, NS, and you need to find the VS. Basically, what is our equation? VP over NP equals VS over NS. 230 over 720 equals VS over 50 over 50. Cross multiplication. 230 times 50 divided by 720 is, yes, 23 volts. Exactly. No, it's not 23. Let me calculate it again. It's around 16 volts, actually. It's not 23. It is 16 volts. 230 times 50 divided by 720. It could never be 23. The current in the input is 1.4 amperes. Calculate the input power. What is power? Hmm. What is power? Power equals VI. Power equals VI. We have to memorize this equation. What's the voltage on the input? What is the voltage in the primary? 230 volts. So voltage 230 volts times the current, which is 1.4. Okay. Um, 320 watts. 320 watts. Yeah, moving on. Question 10. Calculate the number of neutrons. Can you find the number of neutrons? Yes, I can. 90 minus 38. Yes, thank you. 90 minus 38 is 125, right? Yeah, how can we find? Yeah, 90 minus 38 is 52. 52 neutrons. Determine the number of electrons. How can I find the number of electrons? If it is a neutral atom, it would be 38. The same number of protons. Yes, thank you. It decays by emitting beta particles. What are beta particles? The nature of a beta particle is it is an electron. Yes, it is an electron, a negative electron. You can say a negative electron. Hmm. Strontium 90 decays with a half-life of 29 years. A sample contains 16 milligrams. Calculate the time taken until only 2 milligrams of strontium remains in the sample. That's an easy question. First of all, you started off with how many grams? Milligrams. You started off with 16. 16. So you have 16. You started off with 16 milligrams. And you want to reach 2 milligrams. How can I reach 16 from go on from 16 to 2? You never minus. You never minus. What do? You divide. Divide by 2 because this is half-life. Thank you. So when you divide by 2, 16 divided by 2 is 8. Am I done yet? No. Divide by 2 again. 4. Divide by 2 again. 3. 2. So 2 milligrams. You reached 2 milligrams after how many half-lives? After how many half-lives? One, two, three. So basically, you used up 3 half-lives. Okay? You used up how many half-lives? 3 half-lives. So this is the question. If you think about it, 3 half-lives. Each half-life took how many years? Each half-life took how many years? Each half-life took 29 years. 29 times 3, that's it. That's all. That's the whole question. 29 times 3 is, yes, 87 years. Is 87 years. So if you want to think about it, let me quickly draw a table. Okay, I'll quickly draw a table. Maybe this would help out a little. Um, this is the time taken, and this is the amount or the mass. Okay, the time taken initially it was 0 before I started off the experiment, and the mass was 16 milligrams. After 29 years, the mass was 8. After 29 years, what happened? One half-life after 29 years. طيب. After another 29 years, after another 29 years, after which is 58 years basically, 58 years. So what do? You add plus 29. You keep on adding 29. What happened? Another half-life. So the mass is 4 milligrams. The remaining mass is 4 milligrams. After yet another 29 years, another what happened after 87 total of 87 years? The remaining mass was only 2 milligrams. Meaning mass was only 2 milligrams. So basically, after 87 years, you are left with 2 milligrams. Question 11. The sun is a star in our solar system. State the names of 2 other categories of bodies. Yes, you have a lot of things you can say. You have asteroids, you have comets, you have dwarf planets, you have moons, you have a lot of things. Okay, so you can say asteroids, you can say comets, you can say dwarf planets, whatever. The name of the galaxy. What is the name of the galaxy we are living in? Yes, thank you. It is the Milky Way. Hmm, excellent. Describe how the light from distant galaxies gives evidence to support the Big Bang Theory. Okay, Big Bang Theory. Basically, what happens during the or how did we come up with this theory? How did we come up with this theory? The light being produced by very distant galaxies, the light being produced by very distant galaxies was red shifted. What do I mean by red shifted? What do I mean by red shifted? Redshifted means that the light produced by these very distant galaxies has a longer wavelength. When you compare this light to other lights, for example, if I compare the blue light being produced by this very distant galaxy, it has a slightly longer wavelength than the blue light here on Earth. Than the blue light here on Earth. So, in other terms, what should I say? What should I say? Light produced by very distant galaxies, by very distant galaxies, okay, has a longer wavelength, has a longer wavelength than here on Earth, okay, longer wavelength, meaning that it has been red shifted. It has been red, okay, shifted. That's for another question. If he wants to ask what is redshift, you should say that the light being produced by very distant galaxies has a slightly longer wavelength. Okay, and this is an indication. This is proof that the galaxies or they are getting further apart or that the universe is expanding. Okay, this is a proof. Okay, that the universe that the universe is expanding. That's it. Okay.